Hello, hello. How's everybody doing? Excellent. All right, so we're going to be talking about Kube native Java. And you might be wondering, what exactly does that mean? Our good friend Duke is also kind of wondering, like, is this a new stack or something? Is this a new way of doing Java? It's not really, but it is maybe a little bit of a change in mindset. So if you think about our kind of traditional deployments, we would always, over-provision our resources just in case we could handle our load, right? So in this case, you could see for most of the time, we have a bunch of resources that we've provisioned to handle a certain amount of requests per second. And then we see kind of requests fluctuate. And in this unfortunate case, at some point, or fortunate or unfortunate, depending on how you feel about it, your organization is lucky enough to have a lot of requests, but your systems aren't able to handle it because they don't scale fast enough, right? Because that's kind of the traditional world. We'd have these kind of beefy servers, but to change how many resources they can handle, it would require kind of a lot of intervention to make that happen, right? So fast forward to the cloud native world, and I'm sure you've seen this by now, or you know this by now, but the idea is that it can scale based on the demand of the moment, right? So you can have a lot more flexible handling of your requests. You can also see that in this case, the peak does get handled, so we just have enough resources to be able to handle what is coming at us. And then potentially with serverless cloud computing, you can even scale all the way to 0 when there's no requests coming in. You don't use any resources, you don't potentially pay, and then you scale back up when you need it. So this is great. But for our traditional kind of cloud app or Java applications, it's maybe not exactly like this, right? Because here you can see that it goes really nicely along the same lines, and our applications are perfectly able to handle if let's say our Kubernetes controller scales up more pods, that they immediately start up and immediately are able to handle all these requests. Unfortunately, when your application can't scale fast enough to handle this traffic, even if we create more containers, then we have still issues, right? So we need to make sure that our Java applications are able to handle this too. So if we kind of compare traditional Java applications, they were built not for the cloud, right? 20 years ago, we had typically VMs. I mean, and I say 20 years ago, but I know, for a lot of us, that's still today, but that's more the traditional Java, where throughput was at the expense of footprint, right? We'd have, nice big servers, and if you need more throughput, stick some more CPU and memory in there. But you would have long-running processes. You wouldn't have, a lot of times that your application would restart, right? You would try to keep it running as long as you can, and then you have in the Java ecosystem this really rich dynamic behavior to load new features. Now that is great for those kinds of traditional workloads where we have dedicated servers, but in the Kubernetes world, things scale up and down, and the Kubernetes itself creates containers, it reschedules containers, potentially based on, oh, there's more room on this particular node than on this particular node. And it, maybe one container goes down, or maybe, there's more traffic, so it creates some more containers, there's less traffic, so it takes away those containers. So there's a lot more kind of moving pieces, right? So we need to handle this a little bit differently because our throughput is really solved by that scaling of the containers. In the container world and in the Kubernetes world, the footprint becomes a lot more important because the smaller our containers are, the more we can have the flexibility to schedule these containers along the different nodes that we have. We can use those nodes in a really efficient way and potentially use less than we would originally, and potentially have less servers, right? The startup time also becomes really important because if we start up containers, like I showed in the previous graph, we want them to start up fast to be able to handle that traffic, right? And we need to think also about, for example, the JVM itself. which traditionally, during the startup time, it takes a while for it to reach its maximum requests per second, right? It has this warm-up time, which isn't so ideal in the container world. We want it to be immediately reach peak capacity and then handle our traffic accordingly. That's the best way to use Kubernetes. And then thirdly, in the world of containers, we want typically immutable systems, right? So that whole kind of dynamic behavior that we had in Java isn't really so useful in containers, because if we have to do this for every container that starts up, that is, duplicate, triplicate, and so on, work that we shouldn't be doing. If we can do that during build time instead of during the startup, during the runtime, that makes a lot more sense, right? So that's kind of the difference between, let's say, our traditional Java and what we call Kube native Java. So I'm Kevin Dubois. I'm a developer advocate at Red Hat, and this is the topic that we're going to be talking about, of course. I'm a Java champion based in Belgium, and I've been working kind of in this Java and cloud native world for the last 10 years. So maybe I have a little bit of experience to talk about this, but who knows? Anyway, let's talk about some of these Java projects that are answering, kind of this problem. There's quite a few, right? So in the Java world itself, we have several projects. For example, Project Leiden that is trying to solve this startup problem to start up faster and to be more efficient. There's GraalVM to compile Java applications to native binaries. We have, Helidon, Micronaut as kind of cloud native projects. And then, the project that I'm personally involved with is Quarkus. So we're going to see, some examples with Quarkus and Spring Boot. I guess I forgot to put it. Spring Boot also, you have Spring Cloud, and you have a lot of advancements in Spring as well. So let's take a step back and think about this Kubernetes world, right? But before we do that, let's maybe revisit real quick, if you haven't seen this slide of Quarkus. If you've ever seen a talk about Quarkus, you may have already seen this, but it is relevant in this talk, because what I said was important is that we have a smaller footprint and a faster startup time. And you can see here kind of the benchmarking. This is actually quite a few years old already. I think there's been some improvements in the meantime. But you can kind of see the difference between our traditional cloud native stack that uses a certain amount of memory and a certain amount of startup time, 4.3 seconds. And if you think about it, 4.3 seconds may not seem so much, but if you have a container that starts up, and especially in a serverless world, 1, 2, 3, 4, a lot of users are like, why is this application so slow, right? So we want it to start up much faster, because we're paying for that time. So we can see here, kind of in this particular benchmark, that Quarkus running on the JVM is already sub-second in this case. Of course, depends on your use case and everything. And then with a natively compiled Quarkus application, we're really at a couple of milliseconds to start up, which is what we want, right? So we can achieve what perhaps some other languages can also with Java, and we can all keep using Java and the great ecosystem that's around that. So I said in my title, kind of from zero to production grade. So that's what we're going to try to kind of do, is build a small piece of an application, and then we'll end up with this car racing game. If you saw my talk here last year, I did a talk about progressive delivery where we did this car racing game with 2 different versions, and we rolled it out. In this case, we're going to focus a little bit less on the game. Maybe if there's time at the end, we can still play it, because you can scan a QR code, and then you can all kind of shake your phone to make the cars move. We'll see if we have time. But we'll try to break it down by creating this application and then building the necessary components to get this to production. So the architecture of this game is basically when you shake your phone or tap your phone based on the different versions, it sends REST requests to a Quarkus application. It sends those requests onto a Kafka topic, and then basically in our dashboard, we get those events, and then we move the cars along accordingly. So that's kind of, I broke it down into let's say the MVP, right? The smallest components to get started with, which is basically sending REST requests with a post to our Kafka topic, which is what I have here in my application. So you can see here, again, I'm using Quarkus, but a lot of the concepts are going to be the same whether you're using Spring or another stack too. So keep that in mind. But I'll show Quarkus in this case. So we can see it's a fairly typical application. So I have Quarkus REST, and we have a Kafka client. And so here you can see that we have this power. Oh, my files disappeared. No, I want them back. Ah. Where did they go? There they go. All right, and so we have the power resource here, and you can see we have a simple post that receives these power events of type device power, where we have device name and a number of power that we're sending based on how hard you're shaking your phone potentially, right? And then it's going to emit that onto a channel, which in this case is backed by Kafka, so it's going to send it to a Kafka topic. Not necessarily the the point of this talk, but just to give you kind of a little bit of background on this application. And then we can see here the Kafka resource is receiving those events on the Kafka topic, and then we're actually going to save or update values in a database just for kicks and giggles. So I'm going to start up this application on my local machine just to make sure that it all works. This should just take a moment. So I'm running this in the Quarkus dev mode, and then it's going to start a couple test containers as well for the Kafka and the database dependency, because I don't have that running on my local machine. So I should see a couple containers here that are running, and we can see the Red Panda, Postgres, and then the test containers container. That's great. And then we should see the application running. So let's make sure that it is. So we can see here, you have created a Quarkus application, great. And we can see the two endpoints that I created. So the post for posting my power events that would come from your phone, and then a get where I'm getting the results from the database and displaying them. So fairly simple. And maybe I can even try it out in the Quarkus dev mode. So here we can see there are the Kafka topics. And we should see a power topic and no events because we haven't created any. So I'm just going to create one real quick. So I'll go here. I think because I added the Open API SmallRye extension, I can even have I can even try it out. There we go. And then let's call the device my device, and then power. I don't know, let's send 100 power units, whatever that means, and then execute. And then we should see that in the Kafka topic, it should be received. So I'm going to go back to here, topics, and then power. And let's see, yes, my device kind of emitted 100 power units. And then let's also check our endpoint real quick, which was localhost 8080/power, I think. And then, OK, I already inserted two values, a Barbie car and an Oppenheimer car. That was our previous race. And then here's my device with 100 power units. So everything seems to be working, which is great. Yes, I even added tests. Surprise, surprise. And so now I want to, of course, make this go to Kubernetes, right? So the first thing what we need to do before we go to Kubernetes is, well, we need to create a container, right? Who here has experience with creating containers? Just to get an idea, most of you, this is what I would have expected in 2025. Most people have at least some experience with containers. There's a few ways that you can create containers. The most common way is with a Docker file, which I have here too, and I actually have a few. So this is what you actually get when you create a Quarkus application. It provides you with these Docker files. So you see there's a .jvm, there's a .native micro. So based on how you're building your application, it'll use the appropriate Docker file. So we can see here, so basically what a Docker file does is it usually uses like a base image that has some of the necessary components. So in this case, the .jvm has OpenJDK in the base image, so I don't need to give configurations for all that. All I'm doing is just copying my build artifacts into the container image, and then I set some options, and then that's my application in a container. So I'll containerize this real quick. Just if you're wanting to do a native compilation, it's the same thing. You just pass into the build that you want to do native, and then you can also use this Dockerfile native, which has no JVM, so it's smaller and quicker to start up. But it takes a little longer to build, which we don't have a ton of time, so I'm just going to do the JVM one. So I could do Docker build and then pass in the Docker file and then the context. I like the Quarkus CLI, where you can just do Quarkus image build, and then it basically uses that Docker file to build my container image. So kind of same difference. There's also other projects like Jib, where you can add it. You can basically build a container image directly from Maven, so you don't have a dependency on a container build engine on your local machine. There's build packs, so there's different projects, kind of up to you. This is the most standard way, I guess, with a Docker file. So in this case, my build was successful. You can see here that it went through all the steps of the Docker file and then tagged my image with quay.io/Kevin Dubois/demo. And it did that because I have in my application properties already those values defined, right? So you can see here container image registry, group, and name. So it picked those up and then created the container image based on that. If I wasn't using that, then I would have, if I wasn't using the Quarkus CLI, then I would pass those in as parameters to the Docker build. So this was just slightly more convenient. So now I have a container image, and I can push it to my registry to then have it deployed by Kubernetes. So you can do that with Docker push or Podman push. Or you can also use the Quarkus CLI for that. So it's Quarkus image push. And in fact, I could have also just done also build, and then it would build my artifact, build a container image, and push it kind of in one command. So we can also do that. Hopefully, I'm still logged into my Quay registry, and then it should push the image up to this kind of registry. And then from then, I can finally start creating my Kubernetes resources. So this is just going to take a moment. Let's see, it's copying based on how well the internet is working. And then we can see build success, and it was successfully pushed Docker image to the registry. So now I want to, of course, go to Kubernetes. If you've seen Kubernetes and how to interact with it, you might have seen that there's a lot of YAML, right? And this is kind of a really simple example of what you will need to do to deploy your application to Kubernetes. So you need two main components. You need a deployment and you need a service. The deployment is basically defining where your container image is. So you can see here, there's a kind deployment here on the left. And then you can see the name of the deployment. You can see replicas, which basically means how many instances, how many containers or pods in the case of Kubernetes do I want to have running. And then you can see a template with a spec containers that points to where I have the container image living, and then which port is exposed in the container. And then the service basically tells Kubernetes to kind of do its internal networking for this particular pod that's created by the deployment. So that's kind of a lot of information, right? Especially we're Java developers, we like to focus on our code. So there's a few ways that you can kind of get around not having to write too much YAML. So in the Spring documentation, for example, they're like, you can use the kubectl CLI, and then you can create a deployment kind of, and it'll create most of this YAML for you. Quarkus has something kind of similar, even built into the application. So I would have to add a Kubernetes extension to my application. So I'm going to just uncomment this. And then let's see, is my dev mode still running? Yes, it is. So it should reload. And then let's take a look here in our target folder. There should be a Kubernetes folder popping up in just a second because I changed my configuration. And then let's see if it happens. Oops, I'm scrolling a little bit too fast here. OK, let's see if it's going to do it. It should have already popped up because, of course, we're doing our live mode. In the meantime, running through my test, passing, yes. OK, let's see. Why is my, oh, there it is, finally. Wow, took a while. OK, so by just adding this dependency on Kubernetes, the Quarkus application actually created this YAML for me. And as you can see, it's a little more complex than what I was showing on the slide. Added some annotations and labels, which you might need to kind of correlate different things in your application. And we can see that there's the ports and a selector and whatever more. So we have a service and we have a deployment. And it's also pointing to this container image that I created, right? So I can apply this and send this to a Kubernetes cluster. So in my case, I have one running here. Happens to be an OpenShift cluster, which is an implementation of Kubernetes. So right now we see there's no resources, right? Because I haven't done anything yet. So there's a few ways that you can now send this to Kubernetes. One way is to use the kubectl command line interface. If you have IntelliJ, you can just hit the push button here as long as if you have your Kubernetes configuration set, and then it'll also apply the YAML. I personally like the push button here because then I don't have to type too much, which is a little bit awkward here with the thing. So this should push two basically Kubernetes objects, right? The service and the deployment. So let's see if this happens, and we can see, yes, it's up and running, although there are some problems, right? Because, well, when I was running this on my local machine, I was lucky that with test containers, my database and my Kafka cluster were there. Of course, in my, let's say, production environment, that's not there. So, of course, the application is not doing so well. You also see here it says health checks. This application does not have health checks, so we need to take care of that as well. I'll explain that in a second, but in the meantime, I'm going to apply a few more files here to make sure that we have all our resources. So I have this Kafka YAML here, which also has a service and a deployment, which just has an ephemeral Kafka cluster running in one pod, and then our Postgres database, we'll push that up as well, which also has a deployment for the database. And then we have a few more components here, which we'll visit in a second. So this should put the database and the Kafka cluster, and then hopefully this little circle will turn blue if everything is working correctly. It might take a while for it to notice that it wants to try to restart a container if things aren't going well. This is one of the things that Kubernetes does pretty well. When it notices that this container has issues, it'll retry to restart the container a couple times. So there could be some issues still because I haven't actually configured the application in Kubernetes to talk to the database and to the Kafka, right? Because they're running on a specific port, on a specific service. So that's something that needs to be configured as well. So Ready for prod, not so fast, right? Because it's actually not working even though we pushed it to Kubernetes. Because there's a little bit more to just deploying the deployment and the service. We need to expose the service, and then we also need to connect with dependencies. Now, you might have noticed that it was trying to start up, and it said, your application is up and running. Oh, wait, it's not. And so one thing that you definitely want to do when you go to Kubernetes is you want to set health endpoints to tell Kubernetes that your application is healthy, up and running, and that everything inside that container is doing what it's supposed to be doing. In this case, for example, you see this was, we made this application a little bit slower to start up, and then Kubernetes thinks, well, the application is up and running, but in fact, it wasn't ready to receive traffic, right? It took, in this case, 2.6 seconds of, potential downtime. So that's what we can set in our application. We can set these endpoints in our application to say, on this endpoint, I'm going to advertise to Kubernetes that my application is ready to receive traffic, and it has started up. So there are three different probes that you can set. So there's the readiness probe, which you see at the top. Then you can set how many times should it retry to make sure that it's ready. And then a liveness probe, which is basically checking every once in a while to make sure that the application is still up and running, even though we checked and made sure that it was initially up and running, because sometimes things go down, right? So you can configure this yourself. You can create these endpoints and integrate them into your application. If you have if you have an application that uses, for example, microprofile, it's a little bit easier. So microprofile is an open source specification for a few different things that have to do with microservices and by extension Kubernetes. One of them is this health specification, which we're using in Quarkus to create these health endpoints. So fortunately, this is again fairly easy to do. So all we need to do is add this dependency, which is smallRye is an implementation of the microprofile spec. And by adding this extension, the health endpoints will automatically be created. And since I'm using a database as well, it'll also check to make sure that the database is up and running. So it'll create a few different health endpoints. In the meantime, it should also refresh my Kubernetes YAML to add those health endpoints to the YAML as well, so we don't need to write that as well. So let's see here, deployment, and then we should see if it refreshed itself. Not yet. I'll give it a little poke here, and then we should see that there's a couple more things that are going to be added to this YAML once the application refreshes. Let's see. Give it one more second. Come on. If not, I'll show you the health endpoints first, and then it'll be waking up. So here in this Quarkus dev mode, we can also see our endpoints. So q/dev UI, and then let's see. There's the smallRye health. So these health endpoints have been added to my application on q/health. In this case, we can see it in the UI. Status up, and we can see that the reactive messaging is up, so the Kafka connection is up and running, and the database connection is up and running. So that's what we want, right, to make sure that everything is up and running the way that it's supposed to. And then Kubernetes can check this endpoint to make sure that everything is good. So let's go and look at the deployment, and we can see now there's this liveness probe looking for q/health/live. You can of course, make this to custom things too, and a readiness probe, and a startup probe, which is the three kind of probes that Kubernetes expects. So let's apply this to our cluster. So at least we have our endpoints configured, but we also need one more thing to make everything work, which is we need to add the configuration to talk to our dependencies or whatever externalized configuration we want to add to our application. So in Kubernetes, those things are called config maps for your configuration, and then secrets for, let's say, the the secret is an unfortunate naming. Let's say more secret values, but you need to be careful because by default in Kubernetes, the secrets are not encrypted. So you may need, an additional tool like Vault, or there's a couple more solutions coming up in the newer Kubernetes versions. But the idea is that you would put, passwords for the connection to your database in a secret, which is potentially encrypted at rest in Kubernetes. Kind of, let's say, our platform engineer or our system engineer's problem. We can use these secrets anyway for some of these things. A config map, on the other hand, is for the configuration. So it could be like maybe the connection string to our Kafka or to our database. So I created a few of those. Unfortunately, that's not something that you can do with Quarkus. So you do have to create those. So in this case, you can see I created a config map, and I did kind of cheat. I actually did this in the UI of OpenShift, but let's make this a little more Kubernetes only focused, and then in that case you can create these config maps. It's fairly easy to do, so you can do kind config map and then data. For example, here we have the connection string for Kafka. The nice thing is that if we want to change these values on the fly to be applied to all our pods, all we need to change is this config map. We don't have to go into the container to change configurations. We don't need to change our application properties, right? This will actually be picked up by your Java application. And then I also created a secret here for the database connection string, which is basically just Quarkus. All right, so let's push these. So they are encoded, but not encrypted. Okay. Push the config map as well. Now, I need to do one more thing because by adding config maps and secrets, that doesn't mean that my application is actually able to use those. I need to configure my deployment to tell it that it needs to talk to these resources and that it's allowed to talk to these resources, because by default, Kubernetes kind of says, OK, you have a deployment and you have a secret, but is this deployment allowed to access this secret? You need to kind of set that up. So fortunately, there is an extension for that, which is Quarkus Kubernetes config, and that will update my YAML again with a couple more values to connect to these different components. So let's see if everything restarts again. Then we should see in the Kubernetes YAML that's being created a couple more things. So you can see here it created a service account, it created a role binding, and then it created in our deployment at the very end here, all the way down, also this service account. So basically, I'm giving the deployment an access to a service account that says that I have access to this role, which is to view the secrets. So fortunately, this is all done for me by Quarkus. So this is a handy value if you're using Spring. I think it's able to configure some of these things, but you may need to do a little bit more manual massaging. But either way, it can work. So let's push this up too, and then let's see. It's OK. The service didn't change, so we can ignore that error message. Now let's go back to our topology here and see how everything is going. So you can see here, by default, when you push a new deployment in Kubernetes, it does kind of a rolling roll out from one version to another. So hopefully this will work. If not, we'll have to look at the logs to make sure that everything is going. So we can see here, there's a warning. And we can go look at logs here real quick to see what we have missed. Unable to find data source. OK. So maybe there's, I think, there's an actual value in our container. So I think I need to re-push the container with these new values as well. So let's do a real quick container image push, and then everything should roll out, and then hopefully everything will be working. Now, this will make my application work. We have configured our health endpoints to make sure that if it's not working, that Kubernetes is not sending traffic to that particular pod. But like I said, in Java, we don't always have the luxury, or in other languages for that matter, that things start up in microseconds, right? We also don't have the luxury that we have, like very, very small memory footprints. Sometimes we have bigger memory footprints. But our Kubernetes system administrators, they like to have some sort of control over how much your application is actually taking up in the cluster, because there are potentially other resources being used, right? So in Kubernetes, you have this concept of resources where you can define how much memory should your application be allowed to use, and what's the minimum that your application needs to use. And so based on those values, your Kubernetes cluster itself can schedule resources accordingly, across the different clusters to make sure that resource usage does not get starved. Because of course, if we deploy an application and it starts using all the memory, well, that's not so good, right? So there's requests and there's limits. So request is basically the minimum amount that your application needs, and limits is this is the maximum that it's allowed to use. So there's a couple different strategies here, and it's also based on CPU and memory. So for CPU, if your application uses more than it's allowed to, your application might start getting throttled by Kubernetes. It says, well, you're only allowed to use this certain amount of CPU. So if you see your application starting getting slower, it could be that it's using more CPU than it's allowed, so keep that in mind. Memory, on the other hand, is a little bit different, because if your application uses more memory than the limit than it's allowed to use, then Kubernetes will effectively kill that pod and restart it. So you might see like OOM killed, out of memory killed, which is a sure sign that your application is using more memory than it's allowed to. So you need to, kind of work a little bit together between you as the Java developer to know what are the resources that your application is more or less using, and your Kubernetes administrator who wants to know, like, what can we schedule so that everything is, used in the best way possible. So you can kind of play around with these values. There's different schools of thoughts, whether there should be limits or not. On a cluster, that's maybe a story for a different time. But this is definitely something you want to keep in mind. Now, a lot of times, developers come to me and they say, I don't really know exactly how much memory my application is using, which is fair, right? I mean, we need to do some benchmarking. We should be aware of how much it's using, but sometimes we don't know exactly, and maybe once it goes to production, the nice thing is in Kubernetes, you can see relatively easily what your applications are using. But this is an article from our friends at Microsoft here with the link. And they wrote this nice article where they explain all these different permutations. And they also recommended kind of, if you really don't know where to start, this is a good kind of starting point, where they say, give your pod, your application, 2 CPUs, 4 gigs of memory, and make sure you don't set the heap size to more than 75%, because there is an overhead in your pod. And if you set the heap size to more than 75%, it's entirely possible that you will continuously get your pod killed because it's using more memory than it's allowed to, because you have a little bit of overhead of other components in your application. And then they recommend the garbage collector parallel, because you're using 2 CPUs, whereas serial is only meant for 1 CPU, right? So you can use the parallel GC, and then they say use to start with 2 replicas, so 2 different pods, so your traffic can be split between those 2, and Kubernetes will do this automatically. So those are kind of some starting values if you don't know where to start. And then you can pass them into your application this way. So you set the resources in your deployment, so you can set the requests for memory to, for example, 4,000 for 4 megs, CPU to 2 cores, And then in the environment variables in your JDK Java options, you can set, use parallel GC and then set the max RAM percentage to 75. So those are some ideas. Now we can do that, fortunately, with our application properties. So let's see application properties, and I'm going to add. I also needed to set this to make sure that my application is, in fact, using the config map and the secrets. That's probably why it was still failing. You can set, for example, the image pull policy. So by default, it says every time a container starts, pull it from the registry. You can also say if it's not already present in your container, if it's not in your cluster, if it's not cached, then you can use, then use that one. If not, pull it. Then here we set our limits, and then here's our requests, and then finally we set JDK Java options to set those percentages. All right, and then I think that's it. So we'll redeploy it. We can do kubectl apply, just to do it a little bit differently. And then if you do -f, that's for the file name, and then it's in target, Kubernetes, and then kubernetes.yaml. And that should apply all our new stuff again, hopefully. We'll see. OK. Now, our application is up and running. We configured it. We optimized our application. For example, with Quarkus, I could have done a native compilation using GraalVM to go even faster. Everything is great, but now what if something happens in this Kubernetes cluster? So I remember, back in the day, we had problems in production. We had to SSH into each individual server, pour through the logs. That's not really, it is technically an option in Kubernetes environment, but you would have to really go hunt down pods and then find, hopefully that pod is still running to then go in the log. Don't do that, right? There are many ways that you can add proper observability to your application to go find what's going on. So in the Kubernetes world, there's OpenTelemetry, for example. That's a very popular project, and then you can use tracing with something like Jaeger or Tempo, and so there's lots of projects out there. In this case, what I'm adding is OpenTelemetry and a micrometer to also get the metrics of everything that's going on. In addition, I also want to make sure that I have fault tolerance in my application itself to make sure that if there's an issue, if a REST service is down or something, that I can retry and then handle it gracefully if something still goes down. So we want to take care of all those different components as well. So in the interest of time, I'll kind of skip this, but I'll share the repo to make sure that you can see how that all works in this application. But let's maybe go to official production to play our game. So of course, I already deployed it, so we can just kind of play it. So what you're going to see once I share the QR code is you'll see the windmill on the left. And then I think I enabled shaking, so you'll have to shake your phone to make sure that our two little cars are going to race along the track. So you basically can pick between two different team names. I came up with some names that I hope you appreciate. And then we can play the game. So go ahead and scan this QR code. So it's just a direct link to that cluster. It's not using anything. And then you should see that you can pick your team name. And then once you do, then there's a red button for enable shaking. If you have an iPhone, maybe give it permission to the accelerometer. And then you should see a little car spinning. If you can maybe quickly confirm that that's the case, you see a little car spinning. OK, perfect. So I'll give everybody one more moment to scan the QR code for those who haven't yet. OK, 3, 2, 1. And then I'll show the application actually deployed in Kubernetes as well. So we have it in the game secure folder here. So this is the back end, right? So it's using a caching database, and then also has our Kafka cluster. So I'm going to go to the dashboard here. So those are the team names. So last year I did, I forgot the name. There's like this fermented fish. If you open the can, it smells really bad. What's the name of it? Yeah. And the other team was the Schottbuller. My pronunciation is probably really terrible, but the meatballs. So in this case, I thought, let's do it a little bit different. All right, so dashboard, and then we should see, if I log in, the actual game. OK, so if everybody's ready, we should see we have. OK, so the pastry is more popular than the toast, but yeah, we have 74 players on Kanelbuller. I don't know. And then toast Skogen. All right, so it doesn't matter if it's not the same number, it takes the average of the team. So it also means that if you registered, make sure you shake, because otherwise you're kind of holding your team back. So once I hit the start button, start shaking your phone, and then we'll see who wins. 3, 2, 1, go. Start shaking. OK, cars are going. Close race. I'll take a quick picture too. OK, well, there was slight race condition, right? So Team Skogen won the game. Well done. Good shakers. And we can also see who was the best shaker, which is Rosenman. Who was the player with the username Rosenman? Nice. You get come down and get a sticker. All right, well played. So this was, kind of the end point of our game, where we configured everything with health endpoints, with config maps, secrets, connected to a Kafka cluster with high availability. We had 5 different pods running to handle all this traffic. And so this is maybe a good starting point for you to explore the Kubernetes world. My apologies if it's not like super clear. There's only so much we can explain in 50 minutes. So it is kind of a big world out there in the Kubernetes world. We as Java developers don't need to be Kubernetes experts, but I think a little bit of awareness of these different components, make sure that your Java application is configured the right way, that it has, ideally a fast startup time, that it has a small footprint, and that you're kind of aware of the resources, and that you can also kind of afterwards go and track down in your observability stack what actually went wrong. And you can see how long requests are taking and stuff like that. It's pretty important. You want one more? You want revenge? OK, why not? So so it's you can scan it, you can refresh your page, or you can scan the QR code again. Sorry, I see a couple. And then I'll share the slides in just a minute. So I'll hit refresh here. So if OK, 3, 2, 1, start shaking. Let's see if the other team is going to win. Uh-oh, it's really close. Yeah. We got a new winner. Well done. Who's the username? Holly? Nice. You also get a sticker. All right. If you like this talk, please let me know in the ratings. If you didn't like it, don't put it in the ratings. And then the slides are there as well, so you can review all of this. And ping me if you have any questions. I'm happy to answer. Thank you.